So let's consider this question. Y equals the absolute value of x minus, let's say, any value at all, 2. How can we graph this? Again, do not memorize, alright? The expression equates to 0, okay? So you have x minus 2 is equal to 0. X becomes what? 2, alright? So I'll have, so let's say this is the graph of absolute value of x. This is just the graph, okay? We have, this is an expression, x minus 2. So when you equated this to 0, x became what? Positive 2. So that means we are going to what? We are going to move towards the right hand side, okay? And we are going to move towards the right hand side. Say this is what? This is positive, and it's also what? And it's also horizontal. Horizontal, okay? So this becomes horizontal shift to the right hand side by a unit of what? Of 2. Okay, this is positive 2 to the right hand side by a unit of 2. So I'll have my xy this way. Then I have, so let's assume this is the possible values for x. Okay, along my x I have 1, I have 2 over here, okay. So the absolute value becomes to grab this, I have it this way like this, and I have it this way. So the name of this graph is what? Y is equal to absolute value of x minus 2. As simple as that. Okay, so the next one is y equals absolute value of x plus, let's say, 4. To draw this, again, the expression equates to 0. So we have x plus 4 equals 0. So therefore, my x becomes what? Negative 4. Negative implies that we are supposed to what? Move to or towards the left hand side. So far as what? The number line is concerned. So therefore, I have my xy plane over here as usual. Then, so if this is 0, I have negative 1, negative 2, negative 3, and I'm assuming my negative 4 is here. Because I'm taking the absolute value of the expression this way. So I'll just draw a line from here, this way, then something like this. So I have this, and I have this. So the name of this graph is y equals absolute value of x plus 4. As simple as that. Now, the last thing we want to consider is how to graph. Let's say you'll be given a function, okay, and that function contains the radical sign or the square root. How do you graph those functions? Alright, so we've learned about the quadratic function, okay. So if x has the exponent of 2, okay, the degree is 2, you know how it is being drawn. When it is what? Absolute. You know how it is being drawn. What about when you have a radical equation, okay, or a radical function? You'll be given a function under the radical or the square root sign. How do we graph those functions? As well, we consider piecewise function in the future, okay? How to graph piecewise function, alright? Okay. So given that y is equal to square root of x, how do we graph this? So we have it becomes this. You draw your rectangular coordinate system this way, then you have it this way. That is from the origin. You have it this way. As simple as that, okay? Yeah. So what happens if this time around y, which is the original function, y equals square root of x, is transformed? What do I mean by the transformation? So y is equal to square root of x. You have y equals negative square root of x. You have y is equal to square root of negative x. This way, and you have something like something of this nature. How do we graph this function? And we also have y is equal to let's say negative square root of negative x. Viewers, would you like to memorize this? No. Okay, so I want to teach a certain trait. You just have to, if you employ that trait, you will be fine. You don't need to memorize. Alright? Viewers, let's consider this. Okay, so you already know that square root of x, you graph it this way. Why did I do this? So these are the traits. First of all, we will tackle the radicand. Alright? Items under the square root is called radicand or radicals. So, if I consider the radicand over here, is it negative or positive? It's positive. Okay, so I have positive x. So when I consider each quadrant, positive x will be here. Okay, so I have my positive x this way. After tackling the radicand, then I'll move outside, or I'll come and consider the coefficient, okay, of the square root. So here it's also positive. Okay, this is positive. Here. So this represents my y, and this represents what? My x. These are the traits you can employ. Okay. So this is my positive x. Okay, my positive x and this. And here the sign here is equal to positive, represents a positive y axis. So I have my positive over here, y. So therefore, this will be on the first one. You get it out. You don't have to know this. Okay, let's consider the second one. So given that y equals negative the square root of positive x. How do we do this? Okay, so let's consult. Okay, the traits over here. First of all, consider your radicand. Okay, so here, and the radicand denotes, let's say, your x-axis. Okay, so this is positive. Is that also? So I have my positive here, and my y here is what? It's negative. So if I draw my xy plane, all right, this way, where is my positive x-axis? It's here. Okay, positive here. It's here, positive x-axis. And where is my y-axis, the negative? It's where? It's here. This is negative y. So it means I'm going to what? I'm going to draw my graph in this direction. Okay, this direction. I have positive here, and the negative is telling me that, oh, I'm supposed to what? Work within like this side, this zone. Okay, so then I'll have my graph to do what? This way. The trick is so simple. It will help you to know the locations, okay, where to graph them appropriately. Do you get that? So you are done with this. Let's consider the third one. Again, you don't have to memorize. Just use what? The tricks. Okay. Given that y equals square root of negative x, how do we graph this? Viewers, you don't have to memorize. Mathematics is fun, okay? Very simple and fun. Alright, so let's appreciate the procedures, okay, in order to arrive at the safest and what and appropriate answer. So I'll draw my xy plane this way. What do I do next? The radical. Okay, this is what the x and the negative. So I'll work. So this is my positive x and this is my negative x. As this. Alright, so that means I'm going to work here. I have my negative x as this over here. Then here, the sign over here is positive. That also. So positive y. So this is what? This is positive y. Viewers, please take note. This is negative y, this is positive y. So that means I'll work within what? The second what? Quadrant. So positive x. So this is negative x at this side. Positive y here. So I'll work here. So I have it this way like this. As simple as that. Alright. Let's consider the last one. Given that y equals negative square root of negative x. So this time around, my x axis is negative and my y axis is negative. So I'll consult my xy plane this way. Why is my negative x axis? It's here, negative x axis. This is negative y. I have my negative x, then I have my negative y. So that means I'll work within this one quadrant, the third quadrant, alright? So I'll have something like this. Yes, this is the end of the graphs about transformation of a given function. Okay. So having understood the geometric definition for some given functions, let us appreciate the mathematical approach where you'll be given questions and you don't have to use any form of graphical method. Okay. Viewers, let's consider this question. You have a given coordinate or point A. So let A 6, 10 be a point on the curve, and the curve is given by y equals f of x. And we are being told to find the image of the coordinate or the point A under the following transformation. You have 1, f of x plus 2, f of x minus 2, 2 f of x divided by 2, and the last one is negative f of x. Viewers, imagine you can't interpret this, and the rest. You can't do anything over here. That is why you don't have to memorize. You don't memorize mathematics. Alright? Okay. So if you are new here, kindly visit my previous lectures where I have dealt with functions in this form into details. Everything is well said over there. Everything is well explained. Alright? So let's consider the first one. Graph f of x plus 2. Alright? How do we interpret this? What does it mean? So f of x plus 2 simply means you have what? A vertical what? You have a vertical shift, okay? Vertical shift. That means you are going to move upwards, alright? By how many units? By 2 units. Alright, we've been doing this all this while. But this time around, I'm going to do the transformation under this point, the coordinate given. Alright. So the original coordinate given was A, they have 6, 10. Now, under this transformation, and we are saying that it's a vertical shift, this is vertical. So, in physics for mathematics, we attribute x to horizontal and y to the vertical. Okay, so you have the vertical component, you have the horizontal component. Because this is horizontal, it's attributed to the x. This is vertical, it's attributed to y. You are going to apply the same concept over here. So whenever you hear vertical, you are going to lay emphasis to the y side. Horizontal is the x, alright? So having said this, so I have my A. So let me call the image of the A prime, okay? Then I have my x coordinate, which is my 6. I will not touch x because this is what? Vertical. So my main focus is what? On the y coordinate. Okay. So here, because we are moving upwards, okay, vertically upwards, we are going to add the unit to the coordinate. So I'll have what? 10 plus 2. So whenever you are moving upwards, add the units to the coordinate given equation. When you are moving downwards, you subtract. You get that. So we have it this way. So our final answer becomes a prime of 6, 10 plus 2 is 4. So this is the transformation for the first one. And the second one we have, this f of x minus 2. Again, this is what? Either vertical shift. Okay, it's a vertical shift, but this time around downwards. Okay, by how many? 2. So we're moving downwards because it's negative. There's going to be what? Subtraction somewhere. So I was giving this point. This is my original point. I have A with coordinates 6, 10. So I have A prime, then 6, the s coordinate remains constant. Then comma, what do I have? I have 10 over here. So I have my 10 over here. But because it's moving vertically downwards, there's going to be what? Negation minus what? 2. So I have A prime this way, then I have 6, comma, then I have what? 8 this way. See how simple it is. Alright, so let's consider the third one. So, okay, the third one. We have I this way. 2f of x. Remember, we're able to interpret this. This simply means what? We have vertical what? Stretch. This is vertical stretch. Okay. By a scale factor of 2. This. What does it mean? What we are going to do with the vertical, we are going to consider what? The y coordinate. Alright? The y coordinate over here. So given this point, I have A, then 6, 10. Okay. So if I transform this, so A becomes A prime. That's the image of A. Remember, 6 is constant because we are not dealing with horizontal weight. So we have 6. Then I have my comma. Please take note of this. Whenever you are stretching something, you will multiply. Stretch has to do with multiplication because when you multiply it by a certain scale factor, we get enlargement. Alright? So, since this denotes stretch, vertical stretch, so this vertical, which is my 10, so I multiply 10 times the unit or the scale factor by what? By 2. So I have 2 over here. So my image becomes what? 6, what? 20. As simple as that. Okay. I have f of x divided by 2. Okay, this is the same as 1 over 2, then f of what? Of x. It's just the same thing. Alright? So this one again is what? Is vertical. So this is also vertical. But this one will be vertical compression or vertical strain. Why we say strain for compression? Because we have a fraction over here. And 1 over 2 is what? It's far less than what? Than 2. You get it that way? Yeah. So this becomes, because it's vertical, we are going to consider what? The y component, okay, or the y coordinate. Becomes, so I have f of x over 2, which is the same as 1 over 2, then f of x. So this is, so I have a, given that a is 6, 10. So I have a prime, then the horizontal remains constant, okay, 6, then comma. Please, whenever it's vertical shrinkage or vertical compression, we are going to multiply. So whenever it's stretch or compression, okay, we are going to do multiplication over here. So here I have my 10 over here. See the first one, we multiply it by the unit given, which is 2, to get 20. So this time around, we are going to multiply this by what? By the half. So times what? Half this way. So you get a prime, then I have 6, comma, what do I have here? I have what? My 5. So whenever you have a fraction and you are considering whether it's vertical stretch or compression, the fraction will always give you what? It will give you a shrinkage, and the whole number will give you what? The enlargement, okay? And the last question is negative f of x. Viewers, here we are not negating the x. So this one is what? Reflection. This is reflection, okay? In the x-axis. Reflection in the x-axis. So reflection in the x-axis, what are we supposed to do? So reflection in the x-axis. We are given this point. So let's say if you have a point of say s, y. So reflection in the x-axis, you maintain the x, then you negate the y. Okay, this is in the x-axis. S-axis. And for y, so for y-axis, you have a, then comma. You have a s, y. For y-axis, you negate the x, then you maintain your y in that regard, okay? So since this one is reflection in the x-axis, what are we supposed to do? This is reflection in the x-axis. So what are we supposed to do? We are supposed to negate what? The y coordinate. So I have my a, I have 6, 10, and I have a prime becoming. So we maintain what? Our x. The x is here, nothing happens to the x. So we maintain it, and the x here is what? It's 6. Then comma. Here was positive y, here became what? Negative y, so we have negative what? 10. Viewers, this is the end of the lesson. See you next time. Bye.